The F-16 Fighting Falcon is one of the world's most well-known and widely used military aircraft. Half a century after its maiden flight for the US Air Force, it remains the most common fixed-wing military aircraft in service, with over 4,600 units built since 1975 and more than 2,000 operational globally. In 2024, Ukraine became the 30th nation to welcome F-16s into its air force, joining nations as diverse as Israel, Pakistan, Denmark, the Netherlands, Thailand, and Venezuela. Most recently, the US approved the sale of 12 F-16CD Block 70 jets to Peru, underlining the enduring demand for this versatile, multi-purpose plane across the planet. Of course, the F-16s being produced today are a far cry from those produced in the 1970s and 80s. The jet has undergone multiple upgrades over the years to both improve performance and incorporate the latest military technology over the years, with further upgrades ongoing. The F-16s delivered to Ukraine aren't the very latest versions, but they did receive substantial upgrades before delivery. In particular, they received a very special upgrade to their electronic warfare capabilities, geared specifically to giving them the edge in the unique circumstances of Ukraine's ongoing war against the invading Russians. This backstory to the upgrade reveals important details about how modern air warfare is conducted and how Ukraine is using its F-16s in the war. Let's dive into the details. By mid-2025, NATO members had committed to supplying Ukraine with at least 85 F-16s. The Netherlands promised to deliver 24 and had delivered all of them by May 2025. At least 12 of the 19 promised by Denmark have been delivered by the end of February 2025. Norway has reportedly delivered 14, more than double the initially advertised 6 it had promised, and Belgium promised a further 30. Delivery has been delayed, but all 30 are expected to be delivered by 2028. However, not all of the 85 F-16s are destined for active operational roles. At least 18 of the Dutch-supplied F-16s were earmarked for training Ukrainian pilots to operate them, primarily at the European F-16 Training Center in Romania. Some may be used for spare parts. The US, for its part, hasn't supplied any operational F-16s to date. The US Air Force is in the process of replacing its aging F-16s with the next-generation F-35 Lightning IIs, a process which was intended to be complete by the end of 2025. However, due to delays with the rollout of the F-35, the US has been upgrading its vast F-16 fleet with a view to keeping them operational into the 2040s. So there's no shortage of demand for the servicing and upgrading of F-16s, both from the US and the other 30 nations in which the jet is in active service or for spare parts. These are often cannibalized from the US's stockpile of older, non-operational F-16s, and in both these regards, servicing F-16s and supplying spare parts, the US has certainly stepped up to the plate when it comes to Ukraine. In May, photos emerged showing partially disassembled F-16s being loaded onto a Ukrainian charter AN-124 transport aircraft in Arizona. Flight trackers later showed the transport flying to Poland. An Air Force spokesman confirmed that the US has supported the sustainment of European-donated F-16s to Ukraine by providing disused and completely non-operational F-16s to Ukraine for parts. These F-16s were retired from active US use and are not flyable. Importantly, they lack critical components such as an engine or radar and could not be reconstituted for operational use. Then in September, the US Department of Defense awarded a new support contract to Lockheed Martin for servicing of Ukrainian F-16s. The agreement, valued at $25.9 million, covers work to be carried out in Fort Worth, Texas, scheduled for completion by May 2029. Funding comes from the Ukraine Security Assistance Initiative, a US Department of Defense-led funding program to increase Ukraine's capacity to defend itself through training, provision of equipment, and advisory initiatives. The contract includes the development of manuals, documentation, and technical material tailored to the particular requirements of the Ukrainian Air Force, so it not only guarantees immediate support for the transferred aircraft, but lays the foundation for Ukraine to achieve a level of maintenance and operational autonomy framework in the medium term as well. F-16s, like all modern fighter jets, require extensive maintenance and, as noted earlier, regular upgrades. The F-16s supplied to Ukraine are far from new, but most of them have been in service with the air forces from which they originated for decades before delivery. But they did receive several upgrades before they were delivered, and none more important than the secretive upgrades to their electronic warfare capabilities. It's unclear which versions of the F-16 were delivered to Ukraine by Denmark or Norway. The Dutch planes were reportedly of the F-16AM or BM variants, and the Belgian planes of the F-16AM variant. However, all of the planes are believed to have undergone the Block 20 Midlife Update or MLU program, bringing them to more or less modern M6.5 standard. This update included integrating precision-guided weapons for ground attacks and improving cockpit systems, radar, and software. The Dutch fighters are also equipped with pods like the Mars and Recce Light reconnaissance systems and the Lantier navigation and targeting pod, along with the more advanced Lightning AT and sniper pods. These pods can significantly enhance operating conditions, capabilities, and situational awareness. The F-16s were also equipped with an AN/ALR-69A radar warning receiver, which improves the ability to detect and evade incoming threats. Then, crucially, they had their software optimized to handle evolving Russian threats in the spectrum. That's according to the elite US Air Force unit that performs the upgrades, the 68th Electronic Warfare Squadron, or EWS. The 68th EWS was originally constituted as the 68th Station Complement Squadron in 1943, with subsequent redesignations as the 68th Test Support Squadron in 1993 and its current designation in 1999. Today it operates as a unit within the Air Force's 350th Spectrum Warfare Wing, based at Eglin Air Force Base, Florida. The unit serves as the sole provider of missionized software for U.S. combat air forces and the U.S.'s foreign military sales of offensive electronic warfare combat assets. It offers 24-hour contingency reprogramming of EW systems, or in their own words, the 68th EWS is an Air Force Center of Electronic Warfare Excellence, focused on increasing the lethality and survivability of the US and its strategic partners by developing, testing, and delivering full-spectrum electromagnetic warfare support. The squadron consists of 3 flights, SWA, SWB, and SWC. SWA and SWC are composed of engineering and equipment specialists who provide mission data reprogramming for F-15, F-16, and E-3 aircraft for 28 foreign partner nations. SWB includes operational and support staff personnel responsible for testing, IT, software development, management, budget analysis, and security and facility management. The unit's task, among others, is to take data collected on potential threats to F-16s and develop software to help pilots overcome the threats. This could be, for example, the latest radar profile of a Russian Su-35 fighter jet showing up accurately on an F-16 video screen. Or it could be algorithms telling an F-16's defensive measures dispensers when to drop flares or chaff, depending on the known speed and flight characteristics of a specific Russian surface-to-air missile. The unit has historically supported over 70 systems for more than 40 countries. However, according to its chief engineer, the upgrades conducted on the Ukrainian F-16s were a very special case and presented unique challenges. That's because the EW system used on these F-16s was an unfamiliar EW system, not part of the US military inventory. That required the squadron to rapidly understand and reprogram an unfamiliar system under a tight deadline. The 68th EWS embraced the challenge, with the squadron's chief engineer emphasizing that the team felt it was their responsibility to succeed. They felt that the reprogramming was critical to counter evolving Russian threats in the electromagnetic spectrum, including jamming and spoofing. As the chief engineer put it, most reprogramming centers would have said no way when approaching this challenge. It's uncharted policy. We looked at each other and we said, if not us, then who? We're the best people to do this. They assembled a dedicated team comprised of seasoned experts and bright young engineers to approach the reprogramming challenge. The team started with data provided by Denmark and Norway, then adapted their processes to go underneath how the EW system worked. They then sent members to a partner nation lab abroad to collaboratively develop and test the system. This is not our standing operating procedure, said the 68th EWS director. The fact that the team was able to figure out the system in 2 weeks, go in country with a partner to develop a best ever mission data file is unheard of, and is thanks to the talent here in the squadron and the wing. Within the ultra-tight 2-week deadline, the 68th EWS was able to test and verify the unique elements required by the Ukrainians, and even improve the reprogramming process being conducted by all parties. Ukraine has subsequently been onboarded as an official Foreign Military Sales, or FMS, case for the 68th EWS. That enables the unit to provide ongoing reprogramming of the system based on feedback from the Ukrainians, another departure from standard operating procedure. Traditionally, feedback from FMS cases is derived from training environments, but Ukraine will provide combat-tested data to improve capabilities. That could be of vital importance, not just to keep Ukraine's F-16s as capable as possible, but to update F-16s across NATO and other partner nations' F-16 fleets. According to the 68th EWS director, when you're talking about a near-peer conflict, you need all of your coalition partners to operate with the same playbook so you can achieve spectrum dominance. One F-16 with a reprogrammed pod won't achieve air dominance alone, but it may give you a pocket of air superiority for a moment's time to achieve an objective that has strategic importance and impact. So what EW upgrades did the 68th EWS install, and how are they making a difference in Ukraine? That's unfortunately mostly a matter of speculation. The exact electronic warfare capabilities that Ukrainian jets have received are, at least for now, top secret. From the few images that have emerged, the Danish F-16s, which were the only ones available when the 68th EWS was working on them, were fitted with pylons from Danish defense contractor Terma. These pylons can carry electronic warfare jammers and dispensers for decoy flares and chaff, and are integrated with the jet's internal self-protection suite. Terma are also almost responsible for the unfamiliar EW system, whose software the 68th EWS upgraded, the ALQ-213V Electronic Warfare Management Unit, or EWMU. The hardware part of the system consists of a combined controller and controller unit. It's part of Terma's world-renowned range of controllers which, according to the company, are in service on more than 2,500 aircraft and on at least 25 different platform types in more than 15 different countries worldwide. The unit combines a small form factor with a powerful platform and cockpit control unit, which offer many configurable interfaces and robust computing capability. That enables easy integration of any ASE sensor or effector system in addition to aircraft core functions and makes it relatively straightforward to upgrade. As a result of this rather compelling profile, it's been installed on the US Navy's P-8A Poseidon multi-mission maritime aircraft and on the Dutch Air Force's NH-90 helicopters, as a component of Terma's modular aircraft survivability equipment pod. It was also installed on the Taiwan Air Force's fleet of 144 F-16Vs and in a set of upgraded F-16s supplied by the US to South Korea in 2015. Most pertinently, the Danish Air Force installed the ALQ-213V system into its F-16s during the 2000s as part of an announced National Military Enhancement contract. So it's extremely likely that this is the EWMU that was installed on the F-16s Denmark gifted to Ukraine and upgraded by the 68th EWS. As for the software, the source code and algorithms it uses are highly classified, as it should be. However, we have a pretty clear idea of what it does. Software for EWMUs typically stores data about potential threats like the wavelengths of enemy radars, the flight characteristics and radar signatures of enemy missiles. In some cases, specific data that can enable the airplane's own defense system to fake its location or radar signature on an enemy radar screen is also included. When the F-16's sensors detect frequencies during flight, the software must detect, categorize, and respond to the waveforms as accurately as possible, using the data in this built-in threat library. Of course, the operators of air defense radars and other emitters know that their signatures are exposed to enemy electronic warfare systems, so to reduce vulnerability to electronic warfare attacks, they have long relied on tactics like switching between different operating modes, hopping frequencies, or taking similar actions that alter the output signature. That means, in turn, electronic warfare systems have to be routinely reprogrammed to update their databanks to respond to these evolving threats. New or modified drones, missiles, glide bombs, and the like from both sides appear regularly in the Ukrainian skies. They emit different signatures, which then need to be added to the EWMU's threat library. Fortunately for Ukraine, the US's electronic warfare threat libraries are the most comprehensive in the world. Some might even say that they're one of the biggest advantages available to America's armed forces compared to its main rivals. A large part of that comes down to the US's ubiquitous surveillance capabilities. It's almost inconceivable that the software upgrades performed by the 68th EWS didn't include installing the most comprehensive database of Russian threat signatures possible. And given the vast amounts of data about Russian weaponry that's been harvested by the US over the past few years, that threat library might contain more electronic detail about Russian weapons than even the Russians possess. Near-constant flights by NATO spy planes and spy drones over the Black Sea, just across from Russian-controlled airspace, have taken place practically daily since the invasion began. RQ-4 Global Hawk long-endurance surveillance drones and their maritime-configured version, the MQ-4C Triton, have been regularly tracked. They've been joined by manned aircraft like the RC-135 Rivet Joint Specialized Electronic Intelligence Aircraft and the aforementioned P-8A Poseidons. Alongside regular military surveillance, their mission has been, and continues to be, collecting exactly the kind of electronic warfare data needed by the 68th EWS programmers to write effective algorithms. The threat profile library uploaded to the Ukrainian F-16s is bound to have included all the Russian information collected during the first 30 months of the war. Given the sheer scale of the data collection operation during that period, it's likely that included, down to the millimeter, the frequencies and/or flight profiles for every modern air-to-air missile, air defense system, and aircraft operated by the Russian military. It's even possible that thanks to the upgrade, Ukraine's F-16s have been electronically tweaked to find and target Russia's latest Su-57 stealth fighter jet, or dodge Russia's top-of-the-line S-400 surface-to-air missile. Of course, the war has evolved significantly in the year that has passed since the upgrade was installed, and will continue to do so. There are any number of new or modified Russian drones, missiles, electronic warfare systems, emissions-altering tactics, and so on, whose signatures will need to be uploaded to keep the F-16's threat library in an optimal state. That's impossible without a system that can record new signatures and upload them all to relevant threat libraries in real time. It's the holy grail of electronic warfare, and the US is working on precisely such a system, but there's no indication as yet that such a system is ready, let alone available. So for now, the most likely option for Ukraine to keep its F-16's EWMUs up to date is via manual, on-the-ground updates by 68th EWS techies. This might well be possible from the 2 new truck-mounted complexes that Ukraine introduced in 2025 to support its US-made F-16 fighter jets. These systems, developed and provided by the Come Back Alive group with support from Ukraine's military and energy sector, make it possible for F-16 operations and repairs to take place from a variety of locations, not just fixed bases. The location of Ukraine's F-16s and Mirage 2000s is a heavily guarded secret. However, the bases where they are most likely to be parked have been consistently hammered by Russia since the war began, and especially since the F-16s started arriving. The Starokostiantini airfield, Ukraine's largest military airbase, has been hit at least 13 times with Kinzhal and other heavy missiles. So Ukraine keeps its F-16s in small groups and moves them around between locations. Of the new mobile complexes designed to expedite this process, the first has a command post and workstations for mission planning and briefings for pilots, as well as space for personnel to rest. The second comes with a workshop for testing and prepping weapons and trucks for putting munitions on the planes. It's entirely conceivable that regular EWMU updates could be done from here. But even a fully up-to-date threat library and EWMU system isn't a magic bullet that will turn Ukraine's F-16s into the weapon that wins the war. Ukraine simply doesn't have enough of them to seriously challenge Russia in the skies. Even if it had the hundreds of planes that would take, it would take years before it has enough pilots skilled enough to make the most of them. That said, the knowledge that Ukraine's F-16s are equipped to identify and counter almost any Russian threat has undoubtedly complicated already difficult mission planning for the Russian Air Force and EW teams. How can they be sure if a Russian Su-35 fighter's radars will detect an upgraded Ukrainian F-16 or vice versa? What if the F-16's EWMU knows the frequencies that Russian missile radars use so that the Ukrainian fighter pilot can punch flares or just present a flight profile that makes it impossible for his Russian opponent to target it? This upgrade means that engaging a Ukrainian F-16, or even approaching airspace where a Ukrainian F-16 might be, is a new risk for Russian pilots and mission planners. Anywhere the Russian Air Force thinks a Ukrainian F-16 might be present, Russian air operations will almost certainly be compelled to be more careful and less aggressive. The upgraded EWMU is also likely to have contributed to the very small numbers of F-16s that Ukraine has lost, despite reportedly losing them daily throughout 2025. True, Ukraine is primarily using them to supplement the air defense around its main cities and not for offensive missions, so they're generally far behind the front lines and immediate danger. Still, of the 4 F-16s known to have been down to date, all appear to have either been hit by friendly fire or suffered a technical malfunction or other emergency, not by Russian missiles. Alongside Ukraine's tactic of moving its F-16s around, the upgraded threat library has surely played a role in keeping the planes safe. As the remainder of Ukraine's F-16s are delivered and its pilots' mastery of the new jet inevitably sharpens, that can only be a good thing for the Ukrainian Air Force. Hit the like button if you enjoyed the video and subscribe to the channel to stay up to date with the latest military technology news and all things military. And thank you, as always, for watching.